Hello everyone, a very warm welcome to this video. In this video, we are going to talk about an introduction to Hive and Pig. Well, on a very high level, what we are going to really see in the next couple of videos is what are my options if I'm not a Java developer and I still want to work on Hadoop. So it's very tough to find Java developers and at the same time, it's kind of tough for Java developers to know data analysis pretty well. So is there a way where as a non-Java developer, I can use Hadoop? And the answer is Hive, Pig and Impala. And we'll be looking about all of these in next couple of videos. So let's get started. So let's first understand what is the motivation for Hive and Pig. We'll then get into the basics of Hive. We'll then talk about the basics of Pig. We'll see how do you go about choosing between both of them. There is a hands-on exercise in the next section and we'll be doing that. So now let's look at what is the motivation for Hive and Pig. MapReduce code is typically written in Java, although it can be written in other languages like Perl or Python. Predominantly Java is the first class citizen, but that introduces some problems. For writing MapReduce program, you need a good programmer, a programmer who's good at Java, who understands how to think in terms of MapReduce, understands the problem that we are trying to solve, has enough time to write the code and test it, and who will be available to maintain and update a code in the future for us. Now, finding MapReduce developers is certainly a challenge for a lot of organizations. On the other hand, organizations have a lot of other people in terms of business analysts, data scientists, statisticians, and data analysts. So many organizations have only a few developers who can code MapReduce. Meanwhile, many other people who want to analyze data, as we've seen. So what we really need is a high-level abstraction on top of MapReduce, something that provides an ability to query the data without learning Java or MapReduce. And Hive, Pig, Impala, these are three technologies that will solve those problems. And in the next few videos, we are going to talk about them extensively. So let's first talk about what exactly is Hive. Hive was originally developed at Facebook, provides a very SQL-like language, can be used by people who know SQL. Under the cover, Hive generates a MapReduce job that runs on the cluster. In the next video, we'll have a lot of details on Hive. Enabling Hive requires almost zero effort from the system administrator because it normally runs on the client side. What Hive does is it has a layer of table metadata definition, which we'll be seeing, and you can have tables and partitions, both of them. You can have tables and partitions in Hive. So when you load data in Hive, you are free to use any of the data types. The data types that are available are tiny integer, integer, big int, boolean, double. You can also have advanced data types or constructors like array, map, or struct. So when you load data, you are free to choose any of these. Hive Metastore is a database that contains the table definitions, and in the next video, we are going to deal with Hive Metastore. Hive tables are typically stored in warehouse. Again, the next video will get into a lot of details. And you can also create external tables, more details in the next video. Now, the point is Hive does not convert your data into anything. Hive still stores all your data in text files with a certain delimiter. And if you don't have a delimiter, still there is no problem because you can write a regular expression that can basically take care of, storing your data. How do you start working on Hive, or how do you launch the Hive Shell? To launch the Hive Shell, you got to go to command line and just type Hive. Once you're on the Hive prompt, you are free to run your SQL queries and Hive will convert them to MapReduce for you. A few examples here. So you start with show tables. So once you are into Hive, you can do a show tables. You can create a table. So let's say here we are creating a table called Leo Tolstoy. In that we have decided to have two fields, frequency and word. And when the data would get loaded, we are already setting an expectation that it's a tab separated data which is stored as a text file. Once you have created a table, you haven't still loaded the data. You can basically run a describe command to get the structure of that particular table. So when you run a describe command here, you would get frequency, integer, and word string. Once you have created your table, it's time to load the data. There are two ways to load your data. First way being that you load it from one HDFS location to another. In that case, you will simply run a command load data in path, the name of the file, into table Leo Tolstoy. But if your data is coming from local file system, then the command that you need to use is load data local in path. That's the command that will basically load data from one local system or local file system to HDFS. Now, anybody who's fairly familiar with SQL would find himself very comfortable with Hive. You can run queries like select star from Leo Tolstoy limit 10, select star from Leo Tolstoy where frequency is greater than 100, order by frequency descending order. So anybody with any skill on SQL would find himself completely at home. You can even join tables. In the background, it runs MapReduce code. Joining data sets is a complex operation in standard Java MapReduce. That would really take a lot of time to write code. But in Hive, you simply say select your fields from one table and another table, specify the join key, and you're free to have your where clauses. So what you see here is that it's just plain SQL, which is getting converted to MapReduce. What Hive does for you is you don't have to learn MapReduce to really write code in Hive. When you run a select query, you are free to store your output either in another table by doing a kind of insert select. You can actually store the data or output in another HDFS file, or you can print the output to the console. The select statement on the previous slide would write the data to console. To store the results in HDFS or to create a new table, what you would do is insert overwrite table. Overwrite would mean that if this new table has any data, delete that. Insert overwrite table, new table. Select word frequency from Shakespeare and join it with another table where frequency is greater than 5. Now the output of this query is actually stored in another table in Hive, and now you're free to query new table also. We are also free to write user defined functions. Let's take an example that we have a collection of a movie, and what we want is when we insert this to a table, we would also want to add additional a field which would just have whether this day was weekday or weekend. So while we are loading with this data, in this case, we can call a Python class or a Python script. So every row would pass through that Python script, and what it gives us is whether this day was a weekday or weekend. So we are free to write our own code or UDFs. The most common UDFs you would find is in Python, but you are free to write UDFs in Java also. So you can basically code your UDFs and dump the data into HDFS with some modification that you want. In this particular case, what we are doing is we are pushing the data along with an additional field weekday or weekend. Hive, being amazingly powerful, has certain limitations. First, you can't have all the standard SQL operations. Hive is not a relational database, neither is it a replacement to Oracle. Hive simply is an interpreter that takes your SQL query and converts that to MapReduce so that you don't have to learn MapReduce. There is no support for update or delete, the reason being simple. HDFS file system cannot let you update the data. There is no support for inserting single rows. It has relatively limited number of built-in functions, and there are as of now no data types for date or time. While this video is recorded, yes, there is no facility to store date and time as a separate field. So this was all about Hive. Just to summarize, Hive is nothing but it's a SQL layer on top of Hadoop, so that you don't have to learn MapReduce, that's the framework for processing, and you don't have to learn Java. You can write your queries or you can express yourself in Hive, and Hive will take care of converting that particular query to a MapReduce program without you having to learn that. So this was all about Hive. The next thing we are going to introduce in this particular video is Pig. Now, on a very high level, you could see that Hive is nothing but SQL on Hadoop. In a very crude way, you can visualize Pig as PLSQL on Hadoop. Pig was originally created at Yahoo to answer similar need to Hive. Many developers did not have Java or MapReduce knowledge required to write standard MapReduce programs, but they still need to query the data. And Pig was there. Pig is a data flow language. The language that it uses is called as Pig Latin, fairly simple syntax, and yes, internally Pig gets converted to a MapReduce program. Pig gets converted to a MapReduce program. Installation of Pig requires no modification on the cluster. The Pig interpreter runs on the client machine and turns Pig into standard Java MapReduce jobs, which are then submitted to the job tracker or resource manager. There is no concept of metadata in Pig because Hive makes you believe that there are tables, but Pig still deals with the normal files. So Pig does not get into the idea of letting people believe that there are tables. Pig still works on the flat files. So let's understand a bit about Pig. In Pig, a single data element is called as atom. Collection of atoms is basically called as a tuple, which is as good as a row in a table. Tuples or a collection of tuples is called as a bag, which is equivalent to a table. Typically, Pig starts loading one or more data sets into bag and then creates a new bag by modifying the existing one. That's the core concept of Pig. Pig supports many features which allow developers to perform sophisticated data analysis without having to write Java MapReduce code. You can do stuff like joining data sets, grouping data sets, loading non-limited, delimited data also, and you are also free to write user-defined functions just as the way we wrote user-defined functions in Hive. Let's take a small example with Pig. We say employees load people.txt as ID name %, the default separator is tab. Then we say anyone with a salary of 100k or more than 100k is rich. We then finally sort the rich by salary descending order. Here what we are trying to do is we are loading a file into a bag called as employees. Then we create a new bag called rich, which consists of all the employees or people who have salary more than or income more than 100k. Finally, we write the contents of that to a sorted bag where we have sorted them, and we finally dump the data to HDFS. Instead of storing that into a file, we could have also dumped the output on the screen. So to show the output on the screen, the command that you use is called as dump. You can also describe a bag, which will tell you what fields are there in the bag. You can also join the two data sets. So you can load two data sets separately and run a join command. These are standard operations. We can also perform group by. Now, how does group by work? Let's understand. When you say a group by, each tuple, it creates a new bag, and each tuple in the group has a keyword called as group. Okay. So just to give you some background, in SQL or RDBMS, we perform a group by and an operation in a single query. So for example, in SQL, we would say select location comma count of star or sum of star from certain table group by a certain field. But in Pig, you will have to do that in two steps. In first step, you just do a group by. When you do a group by, the aggregate function can be performed in the next step. Now, when you do a group by a certain field or multiple fields, those fields, they are denoted with a keyword called as group. So let's look at it here. So here we say that we have grouped people by, let's say, certain value or certain field. And then we say that just names for each EMPS create name, or for each group generate group. Now this group is your keyword for that particular group. So here group by is done in two steps, and that entire group by field actually has a keyword called group. So you can print that directly. Where do you learn more about Pig? You can go to pig.apache.org. So this was all about Pig. What we've seen in this video is that learning MapReduce is not really a mandatory step or a prerequisite to use Hadoop. You are free to use tools like Hive and Pig and still express yourself in terms of SQL and PLSQL. For SQL, Hive is your best friend. For PLSQL, Pig is your best friend. In the next videos, we are going to see how does Hive work internally, how does Pig work internally. We'll be seeing more details about them. And we will also introduce you to another tool called Impala, which is just like Hive with certain enhancements and certain limitations. Thanks for watching this video.